particle of mass 1.6 kg rests on a horizontal table and is attached to one end of a light inextensible string. The string passes over a smooth pulley P fixed at the edge of the table. The other end of the string is attached to a particle B of mass 2.4 kg which hangs freely below the pulley. The system is released from rest with the string taut and with B at the height of 0.5 meters above the ground as shown in the diagram. In the subsequent motion of A does not reach P before B reaches the ground. Now given the table is smooth, find the time taken by B to reach the ground. And given instead the table is rough and the coefficient of friction between A and the table is 3/8, find the total distance traveled by A. You may assume that A does not reach the pulley. So this is the whole statement of these questions, and we are given with the particle A, and this particle has mass of 1.6 kg. And this rests on a horizontal table, and there is of course an extensible string, and the string passes over the pulley. Here is our pulley, and the other end of the string is attached to a particle B of mass 2.4 kg. This is our particle B, and it is hanging at a distance of 0.5 meter from the ground. And we are asked in the first part to find out the time taken by the particle B to reach the ground, and we need to assume in the first part that the table is smooth. Now look at the particle A. In the first part it is given that there is no force of friction because the table is smooth. So the only force which is acting on the particle A is the tension in the string. And this is all we have got as far as the force is concerned. This is the net force. So T is equal to ma according to Newton's second law of motion. It's the only force T. And T is equal to m, and the mass of m is 1.6 A. This is equation number 1. Now we need to look at the particle B. Now as far as the particle B is concerned, it is acted upon by two forces. One force is this T, tension in the string, acting upward, and the other force is acting downward, that is its weight. Now what is the net force which is acting on the particle B? So net force will be W minus T. The motion is in the downward direction, and according to Newton's second law of motion, that would be equal to ma. So W, we know that it is mg minus T is equal to ma. So what is the mass of this particle B? That is 2.4. So 2.4 into G, where G is 10, minus T is equal to m, again 2.4 E, and this will become 24 minus T is equal to 2.4 A. This is our second equation. Now we need to solve these two equations simultaneously in order to calculate the value of A, so that we can use that value of A in order to calculate our requirement in this question, and that is the time taken by the particle B to reach the ground. So from equation number 1, we need to take the value of T, that is 1.6 A, and put it in equation number 2. So first equation number 2, write this equation number 2, and you need to put the value of T 1.6 A from equation number 1 in equation number 2. It will become minus 1.6 A. this is equal to 2.4 A, and 24 is equal to 2.4 A plus 1.6 A, and this will become 24 is equal to that is 4A, and this implies that A is equal to 6 meter per second square. Now if you look at particle B, the particle B initially is at rest, that is U is equal to 0, and it covers a distance of what, 0.5 meter before reaching ground. So the S will be 0.5 meters, and its acceleration is 6 meter per second square, and we need to find out time. So this is all the data we have gathered from the information given in the question, and now we will be using this data in order to find out the value of t by using this equation of motion, that is S is equal to ut plus 1 over 2 at square. Now S is given is 0.5 and u is 0, therefore this whole term will become 0. This is equal to 1 over 2, and the value of A is 6, and t square, this 2 1 and 2 3 6, and t square will become 0.5 divided by 3, and when you calculate it you will get the value of t, that is 0.408 seconds. So this is the time taken by the particle B to reach the ground.